All right, here we go again. Doing homework. Okay. Here we go. Shut this. That. Okay. So Grace and Alex share a sum of money with proportions 5 to 2. Grace gets 3,600 or 3,690 denarii, which is the North Macedonian currency, more than Alex. Okay. So this is kind of a tough problem if you're not comfortable with how ratios work. So we can say that. So we have Grace and Alex share a sum of money. Okay. So there's an amount of money, we don't know what it is. Grace and Alex are going to split it up. The ratios are 5 to 2. Okay. So 5 parts will go to Grace and 2 parts will go to Alex. Now, Alex makes less than Grace. So Grace gets 3,690 denarii, which is just some money. We can just say dollars. Okay. This part actually isn't important. None of that is important. What's important is that Grace gets 3,690 more. So X equals Alex's amount. All right. Actually, let's say let X be Alex's amount. I haven't used X anywhere, so I can just make X equal to whatever I want. And so if X is Alex's amount, then X plus 3,690 is Grace's amount. Why is that? Well, Grace gets 3,690 denarii more, okay? So the ratio of Grace to Alex is 5 to 2. So let's say 5 to 2 equals, this is Grace's amount here, so we'll say X plus 3,690 over X, okay? Now we need to solve for X, so let's cross multiply. I'll multiply both sides by 2, and I'll get 5 equals X plus 3,690 times 2 over X. Okay, and then I'll multiply both sides by X, and I'll get 5X equals 2 times X plus 3,690. Now here I'm going to distribute my 2, right? Remember how to do that. And we get 5X equals 2, actually. So I brought everything up here. 2 times X is 2X. And 2 times 3,690 is 0, 8, 3, 7. 6,000 plus, yeah. Okay. And, if you're allowed to use a calculator, use a calculator. Okay, now we're going to subtract 2x from both sides. We get 3x equals 7,380. And then we divide both sides by 3. And we get x equals 2,460. Let me check that. So, where are we at? Okay, look at me. All right, so now how much money do they have together? This is an important thing. Like, I solved for x, and usually when I solve for x, we're done. But really, no. What they asked was how much money do they have together? So how do we think about that? Well, it's Alex's amount plus Grace's amount. Okay, so we need to do x plus x plus 3690, right? So this is Grace's amount, or Alex's amount. So Alex's amount is x plus Grace's amount, which is x plus 3690, okay? And then I'm going to erase a little bit on the left side here so we can have that room back. So if you need to, just rewind. And the recording will be up for this later as soon as the session ends. So we can take away the parentheses, right, because addition is associative, which is a really important property, and it's helpful. It's not something you have to memorize. It's like a really cool thing. So if anyone needs a video for that, let me know. Say something in the comments, actually. Let me pop into this so I can, on my phone, so I can see your comments while I'm writing. Hopefully someone is watching. My channel, and okay, we live. All right. So x plus x is 2x plus 3690, and we have a value for x here. Okay, we just solved for that, so we can plug that in. So this is 2 times 2460 plus 3690. Okay, and this is going to give us 0294 plus 3690, and then that is going to give us 016. Let me check my work here. Okay, got it. 6. Yeah, so these questions can be tough, and I think the best strategy is to read this out loud to yourself. I recommend this to all my students all the time. I constantly tell people this, and I think it's one of my more kind of likely to be ignored recommendations. People typically don't do what I've said there, and I can only think of a handful of people who have taken me up on this offer, but it works. It just makes so much more sense to you when you read it out loud. And go sentence by sentence. Grace and Alex share a sum of money with proportions 5 to 2. What does that mean to me? If I can't read 5 to 2 out, that means I don't understand the notation, right? So that's a good question to ask. Well, what about sum? What does sum mean? Okay, sum. It's not sum. And that's also a really common thing, is because they're homophones, they have the same sound, we confuse them. Okay, it's a really, really normal thing to make that mistake. But if you can read it out loud fluently and not stumble over it, how you might read a novel, you know, something you're comfortable reading, then you will either know that you understand it, or the part that you stumble over is the part you don't understand. Often it's the part with the notation, that 5:2, okay? Then the second sentence, Grace gets 3,690 denarii. Oh, denarii might be a problem, right? But then in parentheses, this says North Macedonian currency. Okay, maybe I need to look up currency. You know, maybe I've never seen that word before. But then you'll find that currency is money, and North Macedonia is a country. So this is another country's money. So you could just replace denarii with dollars and have no less of an understanding. And so by reading the whole sentence and thinking about the parts I don't understand and simplifying it, suddenly this says Grace has $3,690 more than Alex, okay? The last difficult thing is translating this into some kind of symbolic, you know, some kind of notation here so that we can do algebra to it. And I hate to give you the impression that there are steps, because there are not steps, right? This is just, we're modeling this reality in a way that makes sense mathematically. And sometimes it's hard initially until you get good at it. So keep your spirits up, keep up the hard work, and keep working, because this is good for you, and I think you'll come to enjoy it. All right, let's see. down off my soapbox. Let's see if I can find another problem. Oh, great. Okay. I'm glad it helped you. Please subscribe and like and comment and stuff. It helps people find my channel. It helps me out a lot. And if you have questions, feel free to submit them, cross-post them to my YouTube channel or my Reddit, my subreddit. Okay. I love homework help for questions, but I have to sift through them, and other people are answering them, and sometimes oh wait, this is not right. By the time I get to the problem and then notice, I have to make an attempt at it. I have to see whether or not it's possible for me to solve. Sometimes they're just too hard, or sometimes they take too long. Usually people disappear by that time. Okay. Calculus, applications of vectors. Find velocity given the acceleration and initial condition. Never worked with initial conditions before. Okay. I've tried a lot of answers and tried to sub in the initial condition many ways, but I just don't get it. Okay, maybe I can help with this. It sounds like a physics problem. All right, so entered. Was not defined in this context. So find velocity given the acceleration. Okay. Oh, and the initial condition. All right. Oh, they put C in. Oh, you're so close. Okay, let me. Does anyone answer? No answers yet. Okay, this is cool. So let us take a screen grab of this. All right, let's just do it. Oh, I see. Okay. So it's in IJK notation. So here we go. Let's go over here. We're going to add this image to our problem. And we're going to see that it's not as bad as we thought. So we need to give the velocity, all right, of this function. Now, an important thing to know, let's copy down our givens. We have the acceleration as a function of time equal to 6, and it's going in the j direction, okay? Then we have an initial velocity. This is v at time equals 0, all right? And we have 1 in the I direction, So let's think about what that means. So ijk, right, we have a times I plus b times j, actually let me put little vector hats on top of these, plus c in the k direction, okay? This is the same as a, b, c. Everyone's comfortable with that. But you have to pay very close attention and realize that our acceleration is in the j direction or the y direction, okay? So we have vertical acceleration and an initial velocity in the horizontal direction. So there's two components for our motion here. And the 0 is in the z direction, I guess. And I'm not going to overthink this too much. So if we have a three-dimensional thing, this is x, this is y, and this is z, okay? I'm really proud of myself for having drawn that so nicely. It doesn't always work that way. So we have some initial velocity in this direction, and then we have acceleration in this direction. So what's going to happen is our motion's going to go, maybe I'll draw it on the plane. Our motion's we're going to have this velocity, but we're accelerating this way. So we're going to go off in this thing. We're always going to be going in the x direction because of inertia, but we're going to accelerate to the y direction with a constant acceleration. So we need the velocity. How can we recover velocity from acceleration? All right, we have velocity in the x direction, the I, and we have acceleration in the j direction. How can we recover that? So we know that velocity, the derivative of the velocity function gives us the acceleration function, which means that the integral of the acceleration function gives us the velocity function, right? It's the fundamental theorem of calculus. So let's take the integral of this. Now, and you were so close, you're so close. I see that your answer was wrong there. So we're going to take the integral of a of t dt, which is equal to the integral of 6. And we'll just leave the j off. We're going to keep this in the, we understand this is in the j direction, 6 dt, okay? And you did it correctly, right? This is 6t plus c. You know that you have to have that constant. Well, what is the constant? Here it is our initial velocity, okay? But we have no initial velocity in the j direction, only in the I direction. So what that means is we have this vector. So our x component has, our I component or x component has the initial velocity of 1, okay? Then we have an acceleration. We have 6t in the y direction or the j direction, and then nothing in the z. So this is our velocity function. This is a vector valued function, and that's the answer. Now, if our acceleration had been in the I'm sorry, if we had an initial velocity, like let's say, suppose we had v naught equal to, let's say, I plus j. We had some initial velocity in the I and j direction. This c, the v naught, this is our velocity in the j direction, so we would have had a 6t plus 1, right? This is v naught, so it's the component in the j direction. And you must, I'm sure you're going to get to a problem here shortly where this is going to be the case. If you get there and this doesn't satisfy your curiosity or understanding of what's going on here, please drop it either in homework help or in my subreddit or send me a message. I will make another video. This is an interesting problem. I just was doing some vectors with a student earlier, and I like vectors. It's one of my favorite objects. So yeah, that should be your answer right there. And great question. Keep up the good work. This is gonna make your physics course so much easier. Okay, let's get rid of this. And don't forget to subscribe, please. All right, I had a subscriber goal. My friend told me he wanted me to get 30 subscribers for his birthday, and I missed it by like 11 or 12. So I'm pretty happy with that though. What did you say? No, I'm live streaming.
Oh.
Yeah. My girlfriend, she didn't get internet famous. She's not gonna want that. She told me to shut up. I can't shut up. I'm live. Is this the same user? Particle moves on the ellipse so that at time t greater than or equal to 0, the position given by the vector. Oh, okay, so we have the position vector. Okay. Yeah, I think that's kind of gauche. Be nice to each other, y'all. So these websites, I think this looks like Cengage or something. I'm not sure what website this is. They're tough. You can't tell if you're getting the problem wrong or if you're entering it wrong, and so you just it's a hard time. I saw this one. I was hoping that I could get to this one before it got answered, but I guess not. Oh. Has anyone answered this? Yeah. Oh, this is great. Who is this? James. I like this a lot. That's a great name. A tutor, one of us. This is a nice, concise one, but this is just this. Whoever this is, round of applause to you. Yeah, this is such a great subreddit. People really come in here and answer questions. The mods of this sub went on and said that they would pay people in like they would give them gold or something, Reddit gold, if their question remained unanswered after a certain amount of time, and that's so spot on because it's you never see anything left unanswered. You know, like I can't even go down a few hours and find even after a few minutes, there's no question left unanswered. Okay, let's see this. This has no responses, so posted 5 hours ago. People don't like geometry too much on here, and I definitely understand that. Oh, this is a tough one. All right, given triangle ABC, so ABC is circumscribed with a circle with center O. AH is perpendicular to BC, okay, at point F. G is the midpoint of BH. Okay, so BH is a chord. How do you prove that AC is equal to 2OG? Huh. I really want to do this one, but I also don't want to lose steam. Okay, let's keep this tab open. The homework help subreddit is not really giving us much. Let's try the cheat at math homework. Not that I advocate cheating, but you know, homework is terrible. I feel like we should at least work together on homework. I use Chegg extensively, right? Because I feel as if on these lower level maths, doing many problems and just not wasting your time on struggling with them is a way to get to the kind of cusp of what we're studying right now in math. I don't want to like waste time reinventing the wheel if I can help it. So this Reddit has, or this subreddit has a lot more unsolved problems, which is wild. I see the point, like people don't want to contribute to cheating, so the name turns people off to this. Although there are 44,000 members, but I imagine it's mostly people coming for answers. Okay, so let's see. Let y equal, what's going on? So this has an answer. A relation is defined as yada, yada, yada. Okay, on the interval 5 to 3. Okay. 4x greater than 3. So let's plug in 3 here. So 9 gives us 16, so y equals plus or minus 4. And then here, what values of a and b will be the relation be differentiable at the point 3, 4. I think they must mean continuous. Oh, I see. Yeah, that makes sense. So you need f of 3 equal to g of 3, and you need f prime of 3 equal to g prime of 3 to be differentiable at 3, 4. So this is a relation. So there are actually two y values here. So you could use either. I wonder if this helped. All right, I guess I could do this one. Let's do this one. Is live stream one word? And like this is, I've taken calculus. I did well in calculus, and I've tutored it a little bit, not too much, but this is such a risk for me to start this with someone potentially coming into the thing. And what if I just mess it up? Currently looks like I'm just in here. Sometimes, so I bring the chat up on my phone, and sometimes it shows myself as two users, the one of me in the browser on my laptop and the one of me in the chat on my phone. And I can't figure out why it will be 2 and why it would not be 2. Okay, so we have a circle. Oh, goodness gracious. So we have a circle, okay, centered at about the origin with radius 5. And so let me draw this with a proper circle. It'll look beautiful. This to 90 degrees. And I'll put you here. Okay, so that is our perfect circle. And then that means I want to make this not really there. Let's just take this away. Okay, so this is 5, -5. And then here's 3. So then we need to get rid of this here. And so we want this to be differentiable at the point. So differentiable implies continuous. Continuous does not necessarily imply differentiable. But if something is differentiable, it means the slope here should be the same as stated by the other Reddit user, which was really smart. So we should have the same slope right here. So let me sketch the slope in orange, which is my favorite color. So our slope should be like this. I just choose that point. We could have chosen the -4, but I choose that point. Right, yeah. So then we'll get rid of this. That will be our slope. And we have a parabola. So we want the parabola to have the same slope. Let's sketch a parabola here. There's a really cool feature, this one, which I haven't used too much, but I get to use it today. And So sketch. Oh. Do I have to draw on this side? Oh, there it goes. Okay. So let's make a parabola. Okay. That's not bad. That's terrible. No. 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 This is not helping at all. It's like x to the fourth. All right, that's close enough. So this can go, and then I'll select this guy. Let's go with this guy. Oh, first we can get the selection. Okay, here's my parabola. And now we can move you about. And we need you to be tangent. All right, so this is the situation we're trying to find, where this is tangent right there and continuous. And so we need this. So what does that mean? So the derivative of this circle and the derivative of this parabola have to be equal at the point 3, 4. That is because their slopes are equal at that point, right? That's what it means to be differentiable. Like the limit of your slope, I should say, at any point is like how do I say that? If this suddenly had a point here, had a cusp, then it would not be differentiable. So we need to have that slope be the same. All right. I should really think about how to make that language make more sense. Okay, this is the part where if you haven't been watching, you should start watching. So we want x squared plus y squared equals 25, and y equals ax squared plus bx plus 7 to have the same slope at the point 3, 4. You could also do the same thing for 3, negative 4 if you wanted. So let's do the derivative here. So we're going to differentiate with respect to x. So this is going to be 2x plus 2y dy dx, and it's going to be equal to 0, right? So we want the slope dy dx, so we're going to solve for that. So we're going to get dy dx. I'm going to subtract 2x and then divide by 2y equals negative x over y. That's beautiful. Okay, gorgeous. Now, what point is this for? The point 3, 4. So we have an x and a y value. So at that point, our slope is negative 3/4. So we want the slope here to be equal to negative 3/4 at the point 3, 4. Okay? We want the slope of this parabola to be equal to the slope of the circle at the point 3, 4. Right? So let's do the same thing. Let's differentiate with respect to x. So dy dx, derivative of y with respect to x, is equal to 2ax plus b. All right? Easy peasy. Now we have that same point, 3, 4. This is the point here is 3, 4. This is where we want the slope to be equal to negative 3/4. So we just plug in 3 for this x here. So the derivative of y with respect to x is equal to 2 times a times 3 plus b. Okay. And this is equal to 6a plus b. And we want this to be equal to, hopefully the picture-in-picture is not in the way, negative 3/4. Okay. So, all right, so this will give us we need to convert this into, so this is a line, and it needs to have the slope negative 3/4. And so this portion of the line is m. So if we see this as y equals mx plus b, the 2a is equal to m. So 2a equals the slope, which is negative 3/4. Okay, and so let's forget this for the moment. So 2a should be negative 3/4. All right, so that's a equal to negative 3/8. All right, so then we can say that, let's plug that in for a here and a here. Negative 3/8, negative 3/8. Now, using the idea that we have a slope intercept here, so we want this line, which is the tangent line, to include the 0.34. So let's say y equals negative 3/8 x plus b. Okay, this will be the final shape of our line. This will give us our b. But we know that we have the 0.34, so we'll say 4 equals negative 3/8 times 3 plus b. And then we can simplify here. This is 4 equal to negative 9/8 plus b, and we will add 9/8 to both sides. So we'll get 32/8 plus 9/8 equal to b. I'm probably running out of room. Let me bring it up here. Which is 41/8. So b equals 41/8. All right. So this, do some more eraser magic here. This is going to go there and there. So this becomes plus 41/8x plus 41/8. So this is our answer. Well, I guess a equals negative 3/8 and b equals 41/8. Okay, that's your answer. I don't know, you never came in with the thing. Hopefully this was not a big giant waste of time. If that helped you, please subscribe, like, comment, all those things. Post questions to my subreddit, cross-post them, I should say, keep posting them in those other subreddits since they're good. And I'll do more screencasts for you. So let me just get rid of all this. I'm not going to do too much more because I need to go to the gym today. Let's take a refresh. Oh, you know what? I should be searching this by new. Ugh. Z-scores, don't get me started on those. People really just do not explain what a Z-score is, or what the idea of a distribution is. Official on, and you always ask questions. Okay, I'm going to do one of yours. A slope tangent. All right. This user always asks questions. Man, I can't read this. I probably could if I sit there and struggled really close to look at it, but that visually is so hard for me to read. So the slope of the tangent to f of x is 1/9 x squared y squared. Okay, so this is like a differential equation. So we have some data. I don't even know what they're asking. The curve passes through this point. Okay. Yeah, I'm not going to work on this. Just take pictures of everything. Just snap a pic of it. If g of 2 equals f of 2 plus h minus f of 2 over h, is that the equivalent to saying g of 2 is equal? Oh. Huh. This is great. Perfect. Okay, good discussion there. Hey, what's up? Leave. Who's this in the chat there? Say what's up to us. Come say hello whenever you come in, just so I can answer more of your questions. Let me check my answers. Need help with this problem. Math. The temperature at any point in space is given by blah. Determine the derivative of t in the direction of the vector. I think they have not asked this question correctly. Oh, okay. I'm terrible at Calc 3. Help. Suppose that we had that 3 monkeys each ate 3 bananas, and another group of 4 monkeys each ate 4 bananas. Then is the average just the total number of bananas eaten divided by the total number of monkeys? Well, I think probably the other way makes more sense. Oh. Yeah. Oh. Yeah. Okay, this is great. I think I'm approaching my limit here. Super good. I've been studying all morning, and this thing is not clear to me. I am so pissed. Oh, hey, y'all. Keep it easy on the YouTube channel. When you're trying to determine the delta value of the limit x squared as x approaches 1 given epsilon equals 0.5, how do you approach the problem and find delta? This is what I do. Okay, good start. All right, let's go. Let's do this. Okay. So, oh man, we got 4 in here? This is crazy. This is 4 people on my live stream. I feel famous. Say what's up, y'all. Talk to me. All right. So, I actually really struggled with epsilon delta proofs when I took my real analysis class. And I don't know why I just had such a mental block for this. But when I went back and looked at the OpenStax text by Strang and I forget the other author's name, Herman maybe or something like that. It really cleared up a lot. It gives you like an intuitive sense for this before they actually make you start working with it. So let's see. So we have f of x equals x squared. And then so the limit as x approaches 1 of x squared equals, so we'll just sub in 1 squared is 1, right? So if this is true, that means that x squared minus 1 absolute value should be less than or equal to delta, right? It's not a delta. And this should imply, if you choose, no matter what you choose delta, that you would get the absolute value, or you would get x minus 1 less than 0.05. Okay, so let me, the delta value of the limit, okay. Oh, I have them backwards actually. So epsilon delta, so 0.05, 0.5, and then we have delta. Okay, so what does this mean? This means we can translate this that negative 0.5 is less than or equal to x squared minus 1, which is less than or equal to 0.5. And that's just from our absolute value definition. And then I think right here what I would probably do is so it might be better to factor it. We could just limit 1, so these ones are always kind of awkward. So let's just add 1 to both sides and see if that plays out. No. So the x squared, that's not going to be our thing here. Hopefully I don't flub this in live with 4 people watching, which is like the most I've ever had in here at once. Okay, let me try and remember how to do this. Yeah, let's factor it. So x plus 1 and then x minus 1. And so you need to like limit it. And we want to get this to, so let's choose, since our thing is 0.5, our epsilon is 0.5, then we can say that how can we limit this? Let me do it without the 0.5 and just see if I just do it with epsilon. So x squared minus 1 is less than or equal to epsilon x squared minus 1 and then so this means epsilon is less than or equal to x minus 1, and so this is what we want to get at, so we need to figure out how to limit that. So since x is approaching 1, x should be very near 1. So let's say, let's choose an epsilon less than 1, since it's supposed to be small. As we can just left it at 0.5. Okay, so we'll divide both sides by x plus 1. And this is where it gets kind of tricky. And so since x is approaching 1, we can say that in all cases, this is going to be, this number will be less than epsilon. Since x is positive, it's approaching 1. So we can say that negative epsilon over x plus 1 is going to be less than or equal to epsilon, or negative epsilon, I should say, because it's dividing by a positive number, so it would shrink, which is less than or equal to x minus 1, which is less than or equal to this. And we can say here again, epsilon would be less than or equal to epsilon divided by some positive number. Okay. Now this is tricky, and whenever I was seeing this, I was like, why do you even know to do that? But it's just like, this is true, and you just need to limit this as much as possible. Like, control the size of it as much as possible. This is always true. If you divide by a positive number, and here x must be a positive number near 1, so you just make the argument. And I don't think you even lose generality with that. I think you still have as much generality. So now we don't care about this bit anymore. Okay, it's gone. We don't care about it. This is what we were trying to prove. And then so let's add, or no, yeah, there we go. So we can add 1 to both sides. So we'll get 1 minus epsilon is less than or equal to x, which is less than or equal to 1 plus epsilon. And then so let's sub in, I'm going to bring this up here. So this is going to be 1 minus 0.5, because that was our epsilon that we were given, which is less than or equal to x, which is less than or equal to, or actually, you know what? Let's just stick with here. Let's just go straight from this. We need x minus 1 to be less than or equal to delta. So let's just say this is equal to delta, and this is equal to negative delta. There you go. That's enough. And this is neg 0.5, and this is 0.5. So this is equal to 0.5, and this is 0.5. And let's think about it. If we plug in 0.5 here, what would we get? So we'd get 0.5 squared is 0.25, minus 1 is negative 0.75. Oh no, does that not work? Oh yeah, that works. Yep. This is less than that. No, that's wrong. It would have been introduced right here. Is this true? So this should be a number near 1. Oh no, that's not true for this case. So x minus 1, this would be true. This is always less than epsilon. But then on the negative side, we have epsilon divided by x plus 1. Yeah. That's true. That's still right. So this is negative epsilon, x equals 1, x minus 1. So epsilon so if you scale this, epsilon should always be less than that. And epsilon should always be greater than that. Okay. Yes. So then we can just drop this. We don't need that anymore. So let's put, oh. Yeah, I was right. I'm sorry. I'm just not a smart man. So this is equal to delta. This is equal to delta. So to get x, we just add 1 to both sides. So delta plus 1 is less than or equal to x. Yeah. So then we said delta is equal to 0.5. So this becomes 0.5 plus, so this is, no, negative 0.5 plus 1 is 0.5. Squared is 0.25. 0.25 minus 1 is 0.75. Absolute value. Okay, let's try the positive. This is the same thing. Help me out if anybody knows the answer to this. Okay, let's look it up. Okay, so boom. So yes, plus 4, square rooted. Okay, that works. Okay, I know that you can do it this way. Let me just do it that way, if you're still with me. I guess you could do this for any limit. I'll have to see why I'm wrong for that. Okay, so f of x equals x squared, and so we want the limit as x approaches 1, which means that by the limit definition, we should have the absolute value of x squared, which we're claiming the limit of this is 1. So x squared minus 1 should be less than epsilon, okay? And then that means x squared minus 1 is less than epsilon, and this is less than negative epsilon. That's by the definition of absolute value. Then we add 1 to both sides, so we get 1 minus epsilon is less than or equal to x squared, which is less than or equal to epsilon, let's say 1 plus epsilon. And then we'll take the square root. The square root of a number, of a positive number, should always be less than it. So this will still be true. So we'll get root 1 minus epsilon less than or equal to x, which is less than or equal to square root of 1 plus epsilon. Let me just make sure x squared. If this is less than x squared, then it would also be less than the square root. Okay. And then we need this to look like our has to be x minus 1 less than delta. Oops. Delta. And so we'll subtract 1 from everything. So we'll get square root of 1 minus epsilon minus 1, x minus 1 and then square root of 1 plus epsilon is minus 1. Okay, so for this one, what you do is you say let delta be equal the minimum, because we want whatever one is smaller of square root of 1 minus epsilon minus 1 and 1 plus epsilon minus 1. And there you have it. Whichever one is smaller. And it should always be this one in this case. The square root, but this still doesn't work. 0.5 square rooted. Oh yeah, that works. Yeah, that works. Okay, we're good. Oops. Let me see. How can I? Let me go into the comments and say. It took me a second. Let's refresh this. So I want to go back. If you are still watching and you don't care about this, just stop watching, because we actually covered this for a minute. Okay, so the definition is if the limit of x squared approaches 1 as x approaches 1, then we would get x squared minus 1, absolute value less than epsilon. It implies that x minus 1 is less than delta. This should be what we get. Okay, god dang. Okay, and so then let's start with that. So we're going to get x squared minus 1 abs less than or equal to epsilon. And so we're going to get epsilon is less than or equal to x plus 1, x minus 1. And we need this one. So then let's divide by x plus 1. Less than or equal to x minus 1, less than or equal to epsilon over x plus 1. And let's add 1 to both sides, and we're going to get 1 minus epsilon over x plus, oh, no, I'm sorry. No, we can't do that. So this always has to be less than. So if I do a number line, this is 0, this is negative epsilon, this is epsilon. And I divide this by a number, it should scale it down to here. If I divide it by a positive number, it should scale it to somewhere in between. And this number is less than, no, this number is less than this number, that's why. Yeah, that's why. So this is less than or equal to epsilon. And then this number is less than, so this is epsilon divided by x plus 1. This is negative epsilon divided by x plus 1. So this is less than or equal to epsilon. That's the correct way. So I just made a mistake. Can you use this? There must be a way to use this. Must be a way to use this. Okay, here's this. Since x is approaching 1, but never equal to 1, okay, okay, from this, we'll divide both sides. So we get negative epsilon over x plus 1 is less than or equal to x minus 1, which is less than or equal to epsilon. Now, since x is approaching 1, this should be near 1 plus 1, but it will never actually equal 1 plus 1. So this number should be always smaller than 2. So x plus 1 is strictly less than 2 because x never equals 1. And so if you divide by a bigger number, you get a smaller number. So this will be greater than negative epsilon divided by 2. And this will be bigger than epsilon divided by 2 will always be less than or equal to epsilon divided by x plus 1, as long as x is approaching 1. So then we can just use this. That'll be fine. So negative epsilon over 2 is less than, I don't think you lose generality there either. Okay. There you go. So this is equal to delta. So delta equals the minimum of that. There you go. And since we know what epsilon is, it's always going to be this one. So let's try it. So this would be 1/4. Did I mess it up again? keep plugging this in for x, and that's not the right thing. This is delta. So x minus 1 implies that, okay, so x minus 1 so x should be delta, which is this. And so this is, x has to be between -1/4 plus 1 and so this is 0.75 x, which is less than 1.25. .75 squared. Ah, there, finally. Okay, I was plugging in delta for x, which is the wrong thing. Wow, okay. Let me chat these people. Yeah. So let's even see the original one that I had was delta would be, it obviously doesn't work, but because negative epsilon, so okay, originally what I was doing was I was starting from here and I was saying negative epsilon over x plus 1 is less than or equal to x minus 1 because that should be a positive number since it's approaching 2. And then, my handwriting is getting worse and worse, x plus 1. And then I was trying to say that this should always be less than, so if here's negative epsilon, then this is negative epsilon over x plus 1. So this is true, actually. This is true. And then this is 0. And then so here is epsilon. Epsilon is less than that. And then so this is epsilon over x plus 1, which is always less than epsilon. So this is the side that I had the problem. But actually, so we don't care what this is less than. We just need to be certain that this number, x minus 1, is less than this number. So that's fine. We can. This should be possible. I think I just was making the mistake when I was checking it. So negative epsilon is less than or equal to x minus 1, which is less than or equal to epsilon. Okay, and then plus 1, so 1 minus epsilon. Oh no, this is what I did. Is less than or equal to 1 plus epsilon. And then we can take, these are both equal to delta. So delta is equal to whatever is less here. so let's use this. So this is 0.5. No, still the same problem. Where is my mistake? If anyone like smarter than me as, which seemingly is not that hard to achieve today, smarter than me in these limit proofs comes along, please post something like, I'm not sure what I'm doing wrong here. 0.5 squared is going to be 0.25 minus 1. And this is 0.75, which is not less than 0.5. So I need a number that puts us let's try. So 1 plus epsilon is 1.5 squared. No, that's more than 2. That's not right either. Why is this not true? Okay, I'm going to end the stream just because this is getting ridiculous, but I'm probably going to have to post another thing for this. This is terrible. Okay, stumped. I'm stumped. I'm stumped. Why does this not work? Use the square root for this one, but yeah, I'm not sure why this doesn't work.